Hello, welcome to our new lesson about triangle congruence postulates. But of course, let's have a short recap. Okay? So we all know that if we are going to have the idea of a congruence, they are the two geometric figures with exactly the same size and shape. So like these figures. Okay? So we also discuss about the corresponding parts. Okay? And we also have the CPCTC. Okay? If we are going to recall, CPCTC stands for the congruent parts of congruent triangles are congruent. Okay? So therefore, if we are going to use that statement for us to prove that the two triangles are congruent, so we are going to have the tick marks on the different parts of the triangles. Okay? So in this given, we have here segment AB is congruent to segment DE. Okay? So that's why, so we may have the tick mark here and here. And then we have number 2, segment BC is congruent to segment EF. Okay, so that's why we should have here 2 tick marks. Okay, and then number 3, segment AC is congruent to segment DF. Okay, so that's why we have here 3 tick marks. Okay, then angle A is congruent to angle D. So we have here this one and this one. And then angle B is congruent to angle E. So we have 1, 2 tick marks, then 1, 2 tick marks. And the last is angle C is congruent to angle F. Okay? So that's why we should have here the 3 tick marks. 1, 2, 3. Okay? And since we have all the tick marks that are congruent on the parts of the sides and angles, so we may say that triangle ABC is congruent to triangle DEF. Okay? So, another sort of review is this slide. We are going to complete each congruence statement. So, we have here, triangle JOY is congruent to what name of the triangle? Yes, we have triangle SAD. That's correct. Next, let's have this one. We have triangle BUY is congruent to what? Yes, triangle TOY. Next, how about this? We have triangle SIT is congruent to what? Yes, triangle SAT is correct. Okay. And we also discussed how we are going to find for the value of x. Okay? So let's find the value of x if triangle DOG is congruent to triangle CAT. Okay? So from the given figure, okay, so we have the given measure of angle O, then angle G, and on the second triangle we have for angle C. Okay? So how are we going to find for the value of x here? Okay? So for you to easily solve this, okay, so you may have the corresponding parts. Okay? So of course, angle O corresponds with angle A. So this is 100 degrees. Then angle G corresponds with angle T. So therefore, this is 45 degrees. And then, now we have the complete information inside this triangle. Okay? So, we are going to use the property of the triangle wherein the sum of all the measures of the angles, of the 3 angles of the triangle is equal to 180 degrees or 180. Okay? So, therefore, if we are going to have this equation, we will now have 4x minus 9 plus 45 plus 100 is equal to 180. Of course, you are going to combine the like terms. So, you will have here 4x equals 100 plus 45 minus 9 is equal to 136. Is equal to 180. And then again, use the addition property of equality. So, you will have here 4x equals 180 minus 136. Then, you will obtain 4x equals 180 minus 136 is equal to 44. And then you're going to divide both sides of the equation by 4 so that you can have the value of your x, which is 11. Okay? And for us to check if we have the correct value of x, so we have to substitute 11 in place of x. So 4 times 11 is 44. Minus 9 is equal to, okay, so we have 35. If we are going to check, 100 plus 45 plus 25 degrees is equal to 0 carry 1, 8, 1. So which is equal to 180. Therefore, the value of x 11 is correct. Okay, question? Okay, so how about this one? Triangle RST is congruent to triangle XYZ. Find the value of n. Okay, so since triangle RST is congruent to triangle XYZ as given, the corresponding parts are congruent. So we may say that, okay, so angle S is congruent or equal to the measure of angle Y. So that's why we are going to equate the two given information. So angle S, which measure 60, is equal to our angle N is 2n plus 10. Then, by solving this equation, you will obtain 50 is equal to 2n, okay? Because you are going to use addition property of equality. And then, you will have here to divide both sides of the equation by 2, so that's why your n is equal to 25. Okay? So, I hope it is clear. Okay? So, how much do you need to know about two triangles to prove that they are congruent? Do you need all 6? The 6 parts to be congruent for you to say that the two triangles are congruent? The answer is a big no. Okay? So, how? How are we going to determine if the two triangles are congruent if those 6 parts, those 6 corresponding parts are not all congruent? Okay? So, we have discussed that congruent triangles are those triangles that have congruent sides and congruent angles. So, the parts of congruent triangles that match are called corresponding parts. Okay? So, let's now proceed with the main topic, proving triangles are congruent. Okay? So, the following properties and definitions may be used to prove that two triangles are congruent. So, the first one is with the use of reflexive property. So, in this given figure, overlapping sides are congruent. Okay? So, again, overlapping sides are congruent in each triangle by using the reflexive property. So, they have the common side. So, we are going to use the reflexive property. Another property, if you have seen this kind of figure and the two triangles are congruent, is with the use of the definition of vertical angle. So, we all know that vertical angles are congruent. All vertical angles are congruent. Another property that we may use is about the alternate interior angles. Okay? So, alternate interior angles are congruent given parallel lines. Okay? So, we have here the alternate interior angles. So, we have this one and this one. And then, we have this one and this one as our alternate interior angles. Okay, so they are congruent. Okay, so we have here the SSS, SAS, and ASA. What are these three? Okay, so these are the 3 ways to prove that triangles are congruent. Even you do not have the 6 corresponding congruent parts of triangles. Okay, so you have to take note that you will not use any bad words. Okay? So, before we proceed, let's get a few things straight. Let's have the angle sandwich. Okay? Which is called the included angle. Okay? So, in this figure, the included angle from our given tick marks on segment AB and segment BC, our included angle here is angle B. And on this figure, we have the segment XY and the segment XZ with the tick marks. The included angle within these two sides is angle X. Okay, so I hope it is clear about the included angle. Again, the angle between two sides. Okay, so we have here triangle YES. Okay, so let's name the included angle in segment YE and segment ES. So the included angle is angle E is correct. How about in segment ES and segment YS? The included angle is, that's correct, angle S. And if we have segment YS and segment YE, the included angle is angle Y. Yes, correct. And another clue, whatever letter is doubled on the given segments, okay, so that is the included angle. So as you have noticed on our given segments. Okay. So how about the included side? Okay. So the included side in this given is side CB or BC. Why? Because we have the mark on angle C and angle B. So the included side there is side BC or side CB. And on this figure, since we have the mark on angle X and angle Z, so therefore our included side here is side XZ. Okay? So to know more about the included side, again, that is the side between two angles. Okay? So let's name the included side between angle Y, okay, and angle E. So that is correct. We have segment YE. How about in angle E and angle S? So we have, yes, segment ES is correct. How about in angle S and angle Y? What is the included side? Yes, that is segment SY or side SY. Okay, any question? Okay, so what are the three congruence postulates in triangles? Okay, so again, those are SSS, SAS, and ASA. So let's have this figure first. Okay, so we have here the SSS or the side congruence postulate. So as you have seen in the figures, so we have the tick marks on the three sides. So therefore, if we are going to have the SSS congruence postulate, all the three sides of one triangle are congruent to all three sides of the other triangle. So that's why we have here SSS congruence postulate. Okay? For another example, we have this figure. Okay? So we have triangle ABC is congruent to triangle DEF by using the SSS congruence postulate. Okay? Another postulate is the SAS or the side angle side congruence postulate. Okay? So we have here the side angle side congruence postulate wherein two sides and the included angle should be taken in this congruence postulate. Two sides and the included angle. So that's why on the previous slide we have discussed about the included angle. Okay? So we have here this kind of congruence postulate. For another example, we have here triangle ABC is congruent to triangle DEF by having the marks on segment AB and segment DE, then angle A with angle D, and then segment AC with segment DF. So that's why we have the side angle side congruence postulate. Again, we have to take note of the included angle. Okay? Next, the last is we have the angle side angle or ASA congruence postulate. So obviously, we have the two angles and the included side, which was also discussed before on the previous slide. Included side. Okay? So we have here the angle side angle, two angles and the included side. If they are congruent, so the two triangles are congruent. Okay, another example is this one. So we have the included side is segment AB and segment DE. Okay, so we have here angle B with angle E, then angle A with angle D. Okay, so that is the included side. Okay? So, you have to take note that there is no SSA postulate. Okay? So, if you are given this kind of tick marks of this kind of figures, so although two sides and an angle are given the tick marks, but again, the angle is not included. So, that's why they are not congruent. Again, there is no SSA postulate. Okay? Another thing that you are going to take note is there is no AAA postulate. Okay? So, there is no AAA congruence postulate. So, if you are given this kind of figure, so they are not congruent. Okay? So, again, the congruence postulates are SSS, SAS, and ASA. Again, no SSA and no AAA. Okay? So, on the following slides, we will determine if the triangles are congruent. If they are, write a congruency statement explaining why they are congruent. Then, state the postulate or rule that you use to determine the congruency. So, let's have this first figure for number 1. We have, so what can you see on the figure? What name of the triangle and what type of congruence postulate you may use. Okay, so that's correct. We have triangle PRS is congruent to triangle PQS by what kind of postulate? That's correct. SAS. Okay. Next, number 2. How about these two triangles? How can you name these two triangles? Okay, so we may have here triangle PQR is congruent to triangle STU by what congruence postulate? Yes, SSS congruence postulate. Next, number 3. What can you say about the two figures? They are? Yes, not congruent. So, not enough information to tell. Okay, next, how about this one? What can you say this on these figures? Okay, they are also not congruent. Okay, yes, you may not use SAS here because on the other figure, there are no tick marks on the other side here, inside RP. Okay, next, number 5, let's have this one. We have, okay, triangle ABC is congruent to triangle EDC by what postulate? Okay, so we have ASA, as you have seen on the markings, on the tick marks. Next, number 6, we have here triangle ACB is congruent to triangle ECD by what? Yes, SAS. So, side, angle, side. Okay, so we have here the vertical angles. Okay, next, number 7. What can you say about the figures? Okay, good idea. Not possible because, again, there is no SSA congruence postulate. Okay, number 8, let's have this one. We have triangle MJK is congruent to triangle KLM by what postulate? Yes, that is SAS, using alternative or alternate interior angles rather. Okay, next, number 9, we have, okay, this is not possible. Again, there is no AAA congruence postulate. And for the last question, let us have here, okay, what is your answer here? Triangle NOP is congruent to triangle NQP by what congruence postulate? Yes, using the SSS. Why? Because we have here to use the reflexive property. Okay? So, is there any question? So, if you don't have, so that's all for this day. Goodbye and God bless.